Hi students, Professor Nugent here. In this video, we're going to review joint hypothesis tests. So if we are given a model, y equals beta naught plus beta 1 times x1 plus beta 2 times x2 plus beta 3 times x3 plus u, and we want to test this null hypothesis, the test that beta 2 equals 0, beta 3 equals 0 against the alternative that either one or the other or both are not equal to 0, so the alternative that the null hypothesis is not true, we must use an f-test. Using the t-test sequentially results in a low-powered test, okay? So the size of the type 1 error is going to be too big. It's going to be too big. We want 5% for a 5% level of significance. We want a type 1 error, expected type 1 error to be about 5%. And if you end up doing the t-test sequentially, then you get a type 1 error that is actually bigger than 5%. So we need to use the f-test to test this thing rather than using t-test sequentially. So how can we do that? Well, if the classical linear model assumptions are satisfied, so if we have homoscedasticity in the errors, then what we can do is run a restricted regression and calculate the F statistic. If the classical linear model assumptions are not satisfied, then we need, so that's if we have heteroscedasticity in the error term, in the residual, then we need to use a heteroscedasticity robust F statistic, and we will discuss that in later videos. For now, we're going to assume that our models, they demonstrate homoscedasticity so that we can just run the restricted regression and calculate the F-stat. So what does it mean to run a restricted regression? Let's look at that. The restricted regression essentially implements the null hypothesis. So the restricted regression is going to be the following. Okay, spelled restricted, right? Restricted is going to be y equals beta naught plus beta 1 x1 plus u. All right, so you can see in the restricted regression, we have essentially implemented the null hypothesis where we set the coefficients on x2 and x3 equal to 0, so they don't show up in the restricted regression. And then the F statistic essentially compares the R squared between the two regressions and corrects for degrees of freedom. So by comparing the two R squared, the R squared from the restricted regression and the R squared from the unrestricted regression, what the F statistic is asking is how much additional sample variation in Y is explained by adding the two variables. So let's look at that R statistic and make that concrete. R statistic, that's the F statistic. We're gonna look at the F statistic. Good grief. Okay, so our F statistic is given by the following equation. F stat is equal to the difference between the R squared in the unrestricted regression minus R squared in the restricted regression divided by Q, where Q is the number of restrictions. And if we are restricting beta 2 and beta 3 equal to 0, then we have 2 restrictions and Q is equal to 2, all over 1 minus R squared in the unrestricted regression divided by N minus K minus 1, where N is the sample size, K, that's the number of included variables in the unrestricted regression. We had 3 minus 1. All right, so again, we're going to compare the R squared from the unrestricted regression to the R squared from the restricted regression. We make a degree of freedom adjustment, and we ask how much additional variation, sample variation in Y, is explained by adding these variables, and if there is enough additional variation explained in Y, then we'll get a large enough F statistic to be able to claim that these variables are statistically significant. All right, and this F statistic, let's make sure that we write this down. Distributed F Q N minus K minus 1. And we can get this critical value using the f.inv function in Excel, where this is going to be the probability, this is q, this is n minus k minus 1. All right. And in this case, if we want the 5% level of significance, then the probability is 0.95 here. So let's look at an example and make this a bit more concrete. Let's say that we are going to predict the salary of some sports players. I don't know who these sports players are. Predicting the salary of sports players. And we run this regression based on the number of years that they've been playing and the number of games per year that they play. And this is equal to 11.22 plus 0.7, 0.0713 times years plus 0.0202 times games per year. We have some standard errors to put underneath these things, 0.11, 0.0125, and 0.0013. We have the R squared of this regression. It is 0.5971. The number of observations, so the number of players, the number of sports players is 353. And let's say that we want to test the null hypothesis that the beta, the coefficient on years, is equal to 0, the coefficient on games per year is equal to 0. So this is a really very kind of like a pessimistic or very strict kind of null hypothesis, because we're essentially asking or testing the hypothesis that none of the included variables are useful for predicting salary. That's what's going on here, right? Because there are only two explanatory variables, and we have a null hypothesis that says none of the included variables are useful for predicting salary. That's what we're going to test against the alternative that the null hypothesis is not true. Okay. So if we're going to carry out this hypothesis, we can run the restricted regression, which implements the null hypothesis, and it sets these coefficients equal to 0. And by doing so, we no longer have any included explanatory independent variables. So the R squared becomes 0. The R squared of the restricted regression is 0 because there are no independent variables. There is no variation in X with which to explain Y, right? So this is actually kind of a simple F statistic to calculate. So I'm going to erase this, but leave just the information that we need. So the F stat, recall that this is R squared of unrestricted minus R squared of restricted divided by Q all over 1 minus R squared of the unrestricted regression divided by N minus K minus 1. And the R squared of the restricted regression is 0. It's 0. And so this comes down to 0.5971 divided by 2 all over 1 minus 0.5971 divided by n minus k minus 1. So we have 353 minus 2 included variables minus 1. So 353 minus 3 gives us 350. So let's finish out this hypothesis test. This F statistic, if I have done my math correctly, is 259.35. And I will leave it to you to check my math. We can get the critical value using Excel. I have plugged into Excel equals f.inv 0.95. Our Q is 2. We have 2 restrictions. Restriction on the beta years, restriction on games year, so Q equals 2. And 350 is the other degrees of freedom. 0.95 because our level of significance that we want is 5%. And Excel gave me a critical value of 3.02. So observe that the test statistic is greater than the critical value. So F stat greater than the critical value. And what does that tell us? Well, folks, we can reject the null in favor of the alternative. And so we conclude that at least one of these variables are useful for predicting salary. That's it for our review for statistical inference. Please check out my videos from Eco 321, where I go in depth in statistical inference for multiple regression, both in terms of restrictions on one coefficient, on multiple coefficients, for additional review. Thank you.